This lesson is 24.1 in the Georgia Accelerated Algebra / GOA book. So you can start with a warm-up. Do you remember what is a perpendicular bisector? An angle bisector? And how to find the midpoint and slope of a segment. Remember, we add the x and divide by 2, add the y, divide by 2, and that gives you your new points. And then the slope, of course, is rise over run. So we're going to subtract y in the numerator and subtract x in the denominator, and that gives us our slope, in this case, 1/3. So we want to prove and apply theorems about perpendicular bisectors and prove and apply theorems about angle bisectors. The new vocabulary: equidistant and locus. When a point is the same distance from two or more objects, the point is said to be equidistant from the objects. The same distance, equidistant. Triangle congruence theorems can be used to prove theorems about equidistant points. And sorry to say, yes, we are going to be doing some proofs again. So we have a perpendicular bisector theorem that says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And I think that in class we've already kind of worked with that. We've talked about that. The converse of the perpendicular bisector theorem is if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So this tells us that we have these segments from the endpoints, and they go to the same point on this line, xy, and this is a perpendicular line to AB, then these are also equidistant. If these are equidistant, these are equidistant. So it's on the perpendicular bisector. A locus is a set of points that satisfies a given condition. The perpendicular bisector of a segment can be defined as the locus of points in the plane that are equidistant from the endpoints of the segment. Remember, whenever we have a line, it also can be part of a plane. So the plane intersects, and all the points in the plane are the locus. We want to find each measure. We're going to find mn. So since ln is 2.6, it shows us that this is perpendicular, these are congruent, so this also has to be 2.6 units. And there it is. BC, we have BC is the whole line. We're given that DC is 12, and we're given that this is perpendicular, and these two segments are congruent to one another. So that means that these two segments also must be congruent to one another. Therefore, BD will be 12, and BC will be 24. And there it is written out, 24 units, of course. Remember the units. Units, inches, centimeters. Just make sure you put on some sort of length units since it's not given. Find TU. TU is this one here. Since these are congruent to one another and this is perpendicular, then this is congruent to this. Just set them equal to each other, solve for x, and substitute that back in. Make sure you're paying attention to how they're doing this. They're giving you the proof because they're saying TU is equal to UV by the perpendicular bisector theorem. We're going to substitute, and so we substitute the values for the segments. Then we subtract 3 from both sides, And that gives us our x is only on one side now. And then we're going to add 17 to both sides and divide by 4. And of course, you know that I like to have it the other direction, but that's okay because we're going to use it. We're going to substitute it back in. It doesn't really matter if I substitute it back into TU or UV, the expression for either one, because we get the same result. But this time they chose to put it into TU, and we get 28.5 units. So pause the video and try this one. So we were told that we had a line L that is perpendicular, and it's a perpendicular bisector, so then we know that these are congruent, we know that these are congruent. So by the perpendicular bisector theorem, DG is equal to EG. We go directly to that because we're looking for DG and substituting in for EG, 14.6. Oh, that was quick. Okay, 14.6 units. Try this one. Pause the video. Since DG equal EG and line L is perpendicular to line DE, it's the perpendicular bisector of DE by the converse of the perpendicular bisector theorem. So by the definition of a segment bisector, DE is equal to 2EF. DE, this is only half of it, so we have to take 2 times that to get the same measurement. Substituting, dividing, and wait, where's our final answer? Oh, there it is. 10.4 units. Remember that the distance between a point and a line is the length of the perpendicular segment from the point to the line. Because when we talk about distance, it's always the shortest distance. So that perpendicular line is the shortest distance. The angle bisector theorem tells us that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. The converse of the angle bisector theorem, if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. These do have to be perpendicular lines. Perpendicular lines. We're always talking about perpendicular lines here. Because if it wasn't, I mean, I could make a line out here, and that's not going to be the same distance as this one. So that way we're consistent. We know that they're going to be the same length because, well, we have to have them perpendicular. I don't know how else to explain that. Based on these theorems, an angle bisector can be defined as the locus of all points in the interior of the angle that are equidistant from the sides of the angle. So we want to find the measure of BC. Well, since CD is 7.2, given that it is an angle bisector because the angles are congruent, then we know that BC has to also be 7.2 units. So they're equal by the angle bisector theorem. Substituting in, we get BC equals 7.2 units. Given the measure, find the measure. Given the measure of angle EFH, I said that backwards, didn't I? Find the measure of EFH, angle EFH, given that the measure of the other angle is 50 degrees. Or is that the whole angle? Let's look. EFG, that's the whole angle, so it has to be 25 degrees. And there it is, 25 degrees. And this is our proof in paragraph form, and then they just finished it up in 2-column form. Now we are going to find the measure of MKL. MKL. And we are given expressions for the two angles, and we can tell from what we're given here that they're going to be congruent to one another. So we set the expressions equal to each other, solve for A, substitute back in, and we get the measure of angle MKL is equal to 38 degrees. Pause the video and try this one. So we are looking for WX, which should be the same as WZ, and we're given that WZ is 3.05. So WX is equal to 3.05 units. Try this one. And this time we're looking for the measure of XYZ, X, Y, Z. Oh, okay, that's this one out here. Whoops. This one out here, XYZ. And we're given that the measure of WYZ is 63 degrees. And we're also given, this other information is given to us so that we know that we can apply the angle bisector theorem, even though now they've added some more and it looks a little different. Still the same thing. And just substituting in, we get 126 degrees, which of course was just doubling the 63 degrees that we were given. John wants to hang a spotlight along the back of a display case. Wires AD and CD are the same length, and A and C are equidistant from B. How do the wires keep the spotlight centered? It is given that AD is congruent to CD, so D is on the perpendicular bisector of segment AC by the converse of the angle bisector theorem. Since B is the midpoint of AC, BD is the perpendicular bisector of AC, therefore the spotlight remains centered under the mounting. That all seemed obvious from the question or from the diagram, but you have to actually show that it can be true, or that it is definitely true. Try this one. So our conclusion is QS bisects angle PQR. So this time they didn't ask you to show it, they just asked you what your conclusion was. Write an equation in point-slope form for the perpendicular bisector of the segment with endpoints C6, -5 and D10, 1. So first we want to graph it. The perpendicular bisector of CD is perpendicular to CD at its midpoint. So we need to find the midpoint first. And we'll just use our midpoint formula to do that. And we get 8, -2. Now we can find the slope of the perpendicular bisector. Oops, pushed the wrong one, I think. And so we have the midpoint, and what other point are we using? Let's back up and look. 6, negative 5. Wait. Yep, 6, negative 5. So this is going to be the slope of the line because these are both on the original line. And then, of course, we find the perpendicular slope by inverting it, flipping it, in other words, and negating it. Since it came out positive, our perpendicular slope will be negative. So it's negative 2 over 3. Now we're going to use the point slope formula to write an equation. The perpendicular bisector of CD has a slope of negative 2/3, and we know that it passes through 8, negative 2. So we can put it in point slope form. Y minus y1, remember your y stays, your x stays. Your y1 is replaced by your value here. Your x1 is replaced by your value here. And of course your slope, that's always what m is. So just putting those values in, we have y plus 2 equal negative 2/3 times the quantity x minus 8. And it didn't tell us what form, so we're good with that. And what else did we need to do? Let's look back. I just said write an equation. However, they went ahead and graphed it. Okay, you try it. So we're going to graph PQ, find the midpoint, and then we need to find the slope. Find the slope of the line and then just flip it and negate it. And you can use either one of the first points that were given to do that. Funny, we got the same thing we did in the example. And then we can write the equation. And you may have chosen the other point. It comes out the same regardless. Of course, always, if you get something like this, always simplify it so that it's y plus 1. And then they graphed it. Here's the lesson quiz. Go ahead and try this out. If you get any of these incorrect, then you'll want to let me know, show me your work that you did with it so we can find the mistake. 32 degrees, 54 degrees, 65 units, 8.6 units. Part 2. And once again, you may have written y minus 5 equal negative 5 halves, x plus 3. That would also be correct. And that's the end of this lesson.